So we're going to look at some coordinate geometry for this current unit. So we've already learned the whole unit. This is just going to do some extra practice problems on the coordinate plane. So coordinate geometry is when you take normal geometry and you just stick it on the coordinate plane, and you have to do some algebra and stuff like that involved. Okay, so these problems can get really challenging, but for now we're going to keep it pretty basic. If I give you a really challenging one, it'll just be in the form of a bonus question on your test. So you should have 4 examples on your note sheet. Make sure you've got that pulled up, otherwise you'll just have to write all this down. We're going to do 2 examples together, and I'm going to give you the chance to do the other 2 on your own. So let's look at our first one here. It says, write an equation in slope-intercept form for the perpendicular bisector, underline that, of the segment with the given endpoints. These 2 endpoints that they give us. Justify your answer just means show your work. Alright, so you don't actually have to have a coordinate plane to do coordinate geometry. I just put it up here to give you a visual of what we're doing for our first problem. So I plotted these 2 points. So here's point A, here's B. It's a line segment. And we want to write the equation of the line that is the perpendicular bisector of this line. Oops, there's the bell. Okay, so that would be like, just kind of eyeballing it, it looks like it'd be a line kind of like, sort of like right there, right? Because that looks like it's perpendicular, and then it would cut it in half, it'd bisect it. Okay, so to do that, we're going to have to find a couple of things. First thing we'll want to do is actually find the midpoint of AB, right? Because we know it's bisecting it, so it's going to go right in the middle. Another thing we could do is find the slope of AB, because we're looking for the line that's perpendicular to that. And if you recall from algebra, perpendicular lines have what we call opposite reciprocal slopes. Okay, so we want the midpoint, and then we want the slope of this line so we can find the 90-degree angle here, opposite reciprocal slopes. Okay, so we're going to start off with that. I wrote out the steps if you want to write these down. First, find the midpoint of AB. Now, I will provide these formulas for you for your test. It's been a while since we've done midpoint. That formula is x1 plus x2 divided by 2. And then y1 plus y2 divided by 2. Okay, so midpoint, remember that's just the average of 2 things. And if you average 2 things, you add them together and divide by 2. So that's all this formula does, is add the x's, divide by 2, add the y's, divide by 2. Okay, if we fill that in, our x1 and x2 are those numbers, so negative 3 plus 4 over 2. And then our y's, 1 and 3. Okay, if we simplify that, we're going to get 1/2 for that x coordinate, and then 2 for the y coordinate. 1/2 comma 2, okay, and if you look at my picture here, if we went 1/2, 2, that does look like the midpoint. Okay, so we got our midpoint. Our second step, we're going to find the slope of this line. Okay, so we're doing a little slope formula. I'm also going to provide that formula. Hopefully you guys know that one though. It's y2 minus y1 over x2 minus x1. Okay, so if we calculate that slope, we would do 3 minus 1 over 4 minus negative 3, which is just 4 plus 3. So we end up with 2/7 for our slope. And that looks right in our picture, right? Up 2 over 7 would get me from here to here. Okay. So our third step is just to take the opposite reciprocal slope. So we got 2/7, so the opposite reciprocal would be negative 7 over 2. Okay, so that is the slope of the line we're looking for, the perpendicular line. All right, so we've got our slope now. We've got a point, right, that midpoint we found. So now we can write the equation of our line that goes through that midpoint and has a slope of negative 7 over 2. So since we have a point and a slope, I'm going to use point slope form, which is y minus y1 equals m times x minus x1. Again, I will provide this formula for your test. Okay, let's plug all the correct things in. So y minus my y1, which is 2, equals my m, which is negative 7 over 2, times my x minus my x1, which is 1/2. Okay, we're almost done. It says write an equation in slope-intercept form, so we need to turn this into y equals mx plus b. So we do that in 2 steps. We distribute this first of all. So distribute that fraction, we'd get negative 7 over 2x, and then negative 7 over 2 times negative 1/2 would be positive 7 over 4, right? Multiply the numerators, multiply denominators. Okay, and then our last step, we would want to just add 2 to both sides, so we get y all by itself over here. So negative 7 over 2x, add 2 to 7/4. That's not too hard. You can do that out to the side, right? Or you can do it in your calculator. So if we do 7/4 plus 2, make that 2 over 1, get a common denominator, right? Which we could do 4. So if this denominator is 4, then this would be 8. So what's that get us? 15 over 4. So it's kind of ugly looking, but that'll happen sometimes. That's okay. So, and I have that right here. Final answer would be negative 7 over 2x plus 15 over 4. That would be the equation of that perpendicular bisector. All right, nice job. Let's have you guys try this one. You can pause it here. Just be really careful working through this. I'm going to go ahead and reveal the answer. You should get 6 over 7x plus 33 over 14. Now, if you didn't get that right and you want to check some of your steps, if you calculated the midpoint, you should have gotten negative 1, 3 over 2, or 1.5, either way. And then if you calculate your slope of CD, you should have gotten negative 7 over 6. So opposite reciprocal would be 6 over 7. So you're using that slope and that point to plug into point slope form. And then if you carefully solve that, you should get this as your final answer. All right, so that's the hardest these coordinate geometry problems are going to be for this unit. Let's look at another type of problem you could have. This one's not bad at all though. So it says find the coordinates of the circumcenter of the triangle with the given vertices. So first thing I would do, and if I give you a problem like this, I will provide an actual coordinate plane. So first thing, I would graph those just to get a visual here. So I already graphed mine. If I want to find the circumcenter, I know that is where the perpendicular bisectors intersect. So I could draw all the perpendicular bisectors and just see where their intersection point is. Now, it's actually just enough to graph 2 of them and see where they intersect, because of course the third one's also going to intersect in that same point. Now, the reason why these ones are pretty easy is because I have made these triangles so that you've got horizontal and vertical lines. And horizontal and vertical lines are really easy to work with on the coordinate plane. So if I find the perpendicular bisector of this side, all I've got to do, I mean, I could do all that math that I just showed you in the previous example, but it's actually, since it's a straight line, straight horizontal line, it's really easy to find the midpoint. Like this is 10 units, so the midpoint would be 5 units. 1, 2, 3, 4, 5. And then you don't have to calculate slopes because I know perpendicularly that's just going to go straight up and down. So that would be my perpendicular bisector of this side. And then the other easiest side to do would be the vertical line here. So this goes up to 6, so our midpoint is 1, 2, 3. So draw that line. That would be the perpendicular bisector of that side. So then their point of intersection here would be my circumcenter, right? Which is the point, what is that? 5, 3. So I wrote out some notes for that if you want to write them down. It says find the equation of 2 of the 3 perpendicular bisectors, then see where they intersect. This is the circumcenter. 5, 3. So you guys go ahead and try this last one. You can pause this. I'm going to reveal the answer.